Let me start with a tiny story. A founder I know was demoing their AI assistant to a prospect. Everything was smooth until the assistant stalled for 2 seconds before answering. The prospect glanced at their phone, then said, "Okay, thanks," and the demo was effectively over. 2 seconds. That stall cost the deal. That's the problem we're solving today.
Why does that happen? The short version, as we stitch models, APIs and cloud functions together, response time becomes variable. Network hiccups, a slow model call, a cold start, any of those can stretch a reply, and suddenly the user feels ignored. When users feel ignored, conversions drop and trust erodes. Simple as that.
Quick vocab you can use in a meeting without sounding like a systems engineer. Median, or P50, is what the typical user experiences. P95 means almost everyone, 95%, gets a response at or under this time. P99 is the near worst case. Think of P95, P99 as how long almost everyone waits versus how long nearly everyone waits. Those percentiles are your real signals, not the rare micro outliers.
So what do we do about it? Introduce latency budgets. The idea is simple. Tie response time expectations to business outcomes. Pick SLO tiers, fast, acceptable, degrade, and map each tier to what the user needs and what the business values. Fast might be under 300 milliseconds for a quick UI action. Acceptable could be under 2 seconds for helpful content. Degrade is a graceful fallback path we accept beyond that. The key is aligning those thresholds to outcomes, not engineering vanity metrics.
Here's a 12-minute routine any founder, product lead or small engineering team can run this week. It's fast and repeatable. Step 1, pick your top 3 user flows that touch customers, maybe chat, lead capture, booking. Step 2, map each flow to a business outcome, conversion, retention, demo success. Step 3, measure perceived time. What does the user actually see and feel? Step 4, set a simple target and owner for each flow, SLO tier, a single metric to watch, and a named person. Step 5, define a lightweight fallback for when the target is missed. That's it. Done in a single 12-minute session and you have an operational baseline.
Now 3 pilots you can run this week. Practical, small, measurable. We'll cover each with quick implementation notes, so it's easy to start.
Support chat. Quick-ack plus cached replies. Goal, never leave a user sitting looking at a spinning cursor. Implementation, immediate one-line acknowledgement within 200-300 milliseconds. Got it, I'm pulling that up. Then show a cached helpful reply while the model generates a tailored answer. Cache common replies for top intents and serve them instantly. Owner, support product lead. Metric, fallback frequency and conversion to full answer.
Pilot B, lead capture, instant acknowledgement, async richer follow-up. Goal, capture attention and confirm action quickly so prospects don't bounce. Implementation, after form or chat capture, immediately show a short confirmation message that includes next steps and an ETA for the detailed reply. Then deliver a richer, personalised follow-up asynchronously. Owner, growth or sales ops. Metric, completion to conversion rate and user drop-off during wait. Pilot C, booking flow with progressive confirmations and human fallback. Goal, protect bookings from AI latency. Implementation, stage the UI. First, immediate confirmation that says we've reserved a slot, finishing details now. Then progressively render additional details as they become available. If the system detects sustained latency, escalate to a human-assisted fallback that confirms by phone or email. Owner, ops or product manager. Metric, booking abandonment and fallback usage. Okay, 60-second listener exercise. Ready? Pick one flow in your product. Set a single target, pick fast, acceptable or degrade and a numeric SLO. Name the owner. Choose one metric to watch, P95 response time or fallback frequency. Run the pilot for 1 day and gather the numbers. That's your minimum viable latency budget experiment. Try it now. Seriously, pause and pick a flow.
Here's a fallback script you can copy and test. Keep it short and human-friendly. Thanks, I've got your request. I'll have a full response in about X minutes. Meanwhile, here's a helpful summary to get you started. That immediate acknowledgement reduces perceived wait and sets an expectation. Test wording or a quick A/B. One version with ETA, one without. Measure satisfaction and conversion.
A few lightweight implementation patterns that work for small teams. Caching common replies. Optimistic UI that shows an expected result while the heavy work finishes. Staged rendering so users see incremental progress. And simple feature flags to turn fallbacks on or off while you test. None of this requires a full observability stack. Start with existing logs and a tiny dashboard.
Observability for non-engineers. Watch a few clear metrics. Median tells you typical experience. P95 shows near worst cases, and fallback frequency reveals when your fallback is triggered. Also track conversion or completion rate for the flow. Use conservative alert rules. Only alert the named owner if P95 is above the SLO for 30 minutes or more. This avoids noisy, panic-inducing alerts.
Operational incident playbook. Short and owned. If alerts fire, 1. Quick read-only rollback or disable the new model or feature. 2. Assign a named owner to own communications. 3. Switch to the fallback path. 4. Run a 5-minute triage and then a short post-incident order within 24 hours with 2 corrective actions. Keep the steps tiny so teams actually do them.
Risks to watch and how we mitigate them. Risk 1. Set budgets too aggressively and you dumb down responses. Mitigation. Start conservative and A/B test enforced behaviour versus read-only to see impact on conversion and satisfaction. Risk 2. Fallbacks feel inconsistent and frustrate repeat users. Mitigation. Design fallbacks as graceful parity, immediate acknowledgement plus ETA, and test them in a short pilot, collecting feedback. Risk 3. Noisy metrics lead to alert fatigue. Mitigation, conservative alert rules, and route alerts to a named owner, then tune thresholds after 2 pilot runs.
Alright, recap time. 3 quick takeaways. 1. Tie latency budgets to business outcomes, not engineering vanity metrics. 2. Run small pilots, quick-ack, lead capture, async follow-up, and staged booking confirmations to protect conversion. 3. Monitor P95 and fallback frequency and use conservative alerts routed to a named owner. One practical next consideration, which single flow will you pilot this week? Pick it, name an owner, and run the 12-minute routine.
If you try one of these pilots, tell us what you learn at @AIEngaged. We read the feedback and it helps shape future episodes. And if you want ongoing operational notes and episode pointers, visit aiengage.com to learn more about the show and our approach. Make AI practical. Thanks for listening.